Hi, everyone. I hope you had a good lunch break. Hope you ate well. I'm Jackie. I'm here with Pong now to tell you more about React, which you first heard about yesterday. But before we dive into new content, let's first remind ourselves of a few concepts. React. Yeah. First up, we have a component tree. As you know, many components can themselves be made up of other components. And the component tree is an abstraction that represents a hierarchy of those components within a web app. Now, one question you might have is, when should I break down a component into smaller ones? There's a couple of things to keep in mind that might help you consider when it's appropriate. The first is that breaking down components can help prevent code from getting too lengthy or difficult to read. Think about it like this. Imagine you're trying to build a house. You're going to have a bathroom, a living room, a kitchen, maybe some stuff on the second floor as well. And building it from the ground up, it would be hard if all you had was a massive blueprint of the entire house, making it difficult to find any individual thing or think about things one at a time. It would be better to have specific plans for each room, so that it's easier for you to find the instructions on how to build, say, the bathroom, because you're gonna want a bathroom, right? Hopefully. The same applies to writing code as well. By the end of this class, you'll have written hundreds, if not thousands of lines of code, and you don't wanna find yourself in a situation where you're scrolling through all of that just to modify something like the color of a button. And so having more components can help you more effectively organize those lines of code. Something else is that components often have parts that encapsulate their own functionality. To explain what I mean, let's say you're trying to build a web app for a shopping mall. In that mall, you have a bunch of different stores, and typically in a mall, each store doesn't really interact with one another, so it might be appropriate for each store to have its own part on your website. Now, because there is different parts on your website that don't interact with one another, it would make sense to divide them into components. Doing this can make it easier to code and also easier to debug later on if you have to. And the bullet. But something else along with that is that a component tree helps you control the flow of information between sections of your app more effectively. If you have all of your code in one file, there's going to be a lot of variables and information that's accessible in like every other part of the file. This can be more prone to bugs because, one, there's a chance that the wrong variables might be used or overwritten, and you might be trying to change one part of the code and inadvertently be affecting functionality elsewhere, which is not something you would want. But generally, a component tree it allows us to structure our code in a way that makes life easier when you're designing a web app. Now, Pong, on identifying some components.
So yesterday we were Mark Zuckerberg building Facebook, and now we're on Twitter. I guess we're like Jack Dorsey or something. Let's try to go through this exercise again. We're going to try to see what people are like. The ideas on how this is. Yeah, exactly. Being common navbar. We call it like left sidebar or something, right sidebar. And in the center, we call it theme. But we should hide the zoom controls.
Oh, yes, you're right.
And then you can further subdivide them into smaller components. So feed, we're thinking user details, tweet, for each of the tweets, and then the sidebars, we can split them up accordingly as well. So back chat there, stay in thoughts.
All right. So yesterday, something else we covered were states and props. Now, I'm going to touch on these rather briefly, but these are two fundamental concepts when it comes to building a website in React. And so I would encourage you that if there's anything that's unclear or you need help on understanding anything, please make sure to reach out to a staff member on Piazza, help you or anything, to make sure that you have this full understanding of states and props, because it would be hard to move forward without it. With that, let's jump into an exercise on props. Here we have a simplified componentry of a hypothetical Twitter app. And on the right, there's a list of options. And I'd like to ask you all, which of these would be appropriate props to be passed down from the Twitter app to its child components? If someone answers, maybe you can get an extra slice at the end of class. Just kidding, there's no more. No? Okay, well, the answer is all of them. All of these could be useful props for, or just useful information for some child component in the hierarchy. And exactly how they're used depends on how you would choose to fetch information in the app later on. But just as an example, for the feed component, we might want to display the list of tweets, which users you're following, and just stuff that might be handy to pass down from the top. Let's look now at the tweet component. Which of these pieces of information would we want to pass down as a prop? Not quite, not quite. I'll explain why in a bit, but not the content. Say again? Yeah, exactly. The post ID. This is because while the poster and the post content is relevant to the tweet itself, the comments and the likes themselves don't really need that information displayed anywhere or to handle anything. But we do need the post ID in order to display the comments and the likes to their recording, to the tweets that they belong to. So that's why this is something, that's why post ID is a prop that we would want to pass down. Does anyone have questions so far? Okay. Oh, that's still me. Now let's talk more on state. A general way to remember the difference between states and props is that we want to make states stay and we want to make props pass. Specifically, we want to make props pass downwards. To work with state, we use the useState function that React gives us. And in order to be able to use it, we want to import it, or we need to import it anytime that in any file that you want to use it. So that's important. And the syntax is as follows. We start with const followed by a bracket containing two values, or two things. The first of which is the name that you want to give the state variable. In this case, it's just value. And then secondly, the setter function that comes with it that allows you to change the value of that variable. Conventionally, it's just the same name, but prefixed with set. So you'll see like set, you'll see later examples, but as an example here, we want to change the value of value to banana. We can just call set value parentheses banana as a string. And then after that, there's useState on the right, where we pass in the initial value. This just means that whenever we create this component, the state variable value will hold whatever initial value we want it to. And this can be any type. It could be number, it could be a string, it could be an array, whether empty or not, anything. And here's just an example of state being initialized in the component. It's called my house, and it contains three state variables, one for keeping track of persons and pets. We can see on the right that their initial values are just empty arrays. There's nothing in there right now. It's empty house. And there's also one called exists, which is set to false. So right now our house doesn't exist. And that's all there is to initializing state. Now, what if we want to modify that state? You might think, based on other things in JavaScript, that you could just use the equal sign, give it a new value like you normally do with any other variable. But when it comes to React, this is actually illegal, or rather, it won't do what you want it to do. In order to properly change the value of a state variable, you have to use its setter function, like the one on the bottom of the code snippet, handle click 1. When executed, will change the value to 69. And this is something that you always want to keep in mind, never to use the equal sign for a state variable. This is because under the hood, it's the setter functions that tells React how to properly update the displays and stuff, whatever's on the screen, based on like what the change is. But you don't have to worry about that. Just remember, always use the setters. Here's a scenario in which we can set a state variable to a different value. In this case, we are setting exists to true. Exists will then hold true, and our house exists, just like that. And it looks pretty simple, right? If we say wanted to write a function that represents buying a dog, we would want to use the setPets function because we want to update the value of the pets variable. And what we pass in is a new array containing all the old contents of pets, and then the string dog at the end. This is done with the concat function here. There's actually a typo. The brackets in the snippet should be parentheses, but it basically does what it looks like it's doing. And by the end of this function call, pets will have a new element, the string dog. Alternatively, we can use something that you learned from the JavaScript lecture a few days ago called the spread operator. So what this does is called object destructuring. If you look at the 3 dots, it just unpacks the elements of pets into its individual elements and adds dog at the end with the comma dog, as you can see in the snippet. And then when you wrap that in brackets, this just creates a new array with the elements of pets and then dog followed after. So functionally, it's the same as what we saw on the previous slide, but this is generally recommended because it allows us to more easily read what's going on. So here we can see, it's an array, we have the brackets, and we have the elements of pets with the spread operator, and then adding a new element, dog, as opposed to a function call, which is maybe a little less intuitive, but functionally they are the same. They do the same thing, in this case at least. Okay, so now that we've talked about initializing state and modifying state, let's take a look at this function. We assume that person starts as an empty array, and all this function is intended to do is to add me to the array that's stored in persons. Syntax is similar to what we saw on the previous slide. And then after that, we print the value that's stored in persons. Now, can someone tell me what they think would be printed in the console when this runs? Would it be A or B? It was 50-50 shot. Someone said A? Well, if you said A, you're correct. Just kidding, you're not correct. Sorry, that's on me. We actually have no guarantee on which answer it would be. And this is because setter functions, or set persons in this case, is an asynchronous function. That means that as we're running through the code, we reach set persons, and it'll do everything that we want it to do by the end. So persons will have the element, the string me in the array, but it does this in the background. So when we call set persons, it'll do this in the background, and console.log will then continue to run immediately. And so because it's asynchronous, there's no guarantee that it finishes before we reach the console.log. And for that reason, it's just something to keep in mind in case you expect your state to be a certain value, but it's maybe not. Yeah, so general takeaway, setting state is an asynchronous process.
Right. So as a note for this, like most of the time it will be A for the person who said A, but again, as Jackie said, there is no guarantee because set person is a asynchronous function. So we don't like deterministically know which one it will fit. So although it'll probably be A, this is still a bad practice. Don't do this. So before we were talking about Twitter, let's get back to this. And I have a problem, I have an example of a problem that I might encounter while trying to build Twitter. So here on the left, I have my Twitter profile on the tweets tab. So I'm looking at my own tweets, but I don't want to do that. I want to look at my likes, like things that I have liked. But the problem is that I split my app into components like this. I have a tabs component that allows you to switch between the different tabs on Twitter, and then a tweet panel that actually displays what's going on. But the tabs component, if you recall from earlier, cannot access the state of tweet panel. So if I set the state in tabs, it's not going to do anything in tweet panel. So we've seen something similar to this problem earlier. Let's try to think through how we could like potentially solve this. Any ideas from the audience? Yeah, that's exactly right. You can store the state in a higher level. So actually, the component that wraps both of these tabs and tweet panel components is the feed component. And we can actually change the state to not be in the tabs component, but in the feed component so that when the state is changed, it will change the state in both of them. But how do we actually go about implementing this? Like the setter for tabs, like you click on a button inside tabs, how does that change the state in a parent component? And before we move on, this is actually a React programmatic approach to a lot of these problems. And to like components need to share some kind of state, they'll just usually have a shared state in the parent component unless you come up with like a different kind of solution through like APIs and whatnot that you might learn in the future. But here we've come up with a solution. Let's see how we can actually implement it. So here I have my feed component. And since we want a shared state in feed, I've defined view state needs to be inside this feed component. Now, I also want to be able to set the feed type, the feed content type in my tabs component, and also access this kind of content type in both of them. So the way you do that is that you use your components and you can actually pass in this setter function as a prop. And we'll see how we access that later when we build the tabs component. In tweet panel, you pass in the content type as a prop. So here in tabs, we see that we are accessing the props. And here, this is just the restructuring notation that we learned about in the JavaScript lecture with the content type and the update type being taken out of this props object. But of course, you can refer to the content type and update type by just doing like props.update type instead of doing this notation that I used. So here I made some divs and some HTML stuff, and in my button I do on click, and here I'm actually able to access the setter function of my parent. And the way I was able to do that was that this setter function was passed in as a prop called update type. And then I'm calling that function inside my child component tabs. And then when you call this function, update type, click on these buttons, it's going to update the state in the parent, which then passes a new content type to both of these child components. And now those we panel know which content to render to go. And to recap, share state by moving it into the parent and passing the state value into the setter as a prop. And if you need to know how to do that, you can always refer to the previous slide. And now we're able to switch between tab panels in my Twitter feed, which is really nice. Now I can see my other tweets and what I've liked. Before we move on, does anyone have any questions about this? All right, I guess I'll move on. So what we saw earlier with NewState that we've been using for the past couple of days is an example of a hook. And we haven't really explained what a hook is, and I won't do that yet. It's just a special kind of function for now. Let's learn about a different kind of hook called use effect. And use effect is used for situations where you want to do something immediately after a state is changed. For example, if you want to add someone to a person's array, and then immediately afterwards print the person's array. And that's why you need this new feature called use effect, because if you just think about the way that we've been working with things, you can't really just like console log the state. Understand something else, a component lifecycle, which is like how a React app like changes and its components change throughout your using of it. So components are actually like restaurants. You've been using the restaurants example a lot, and you'll keep using it. So when you go to a restaurant, you talk to a waiter and you tell them what you want. And that's kind of like a trigger for a cascade of actions that happen. Because the waiter will now go to the kitchen and tell them what you wanted. And the kitchen will figure out how to like make that food. And then once the kitchen has made that food, it will bring that food to your table. And we call this trigger, render, and commit in the React world. And this is something that actually happens in React too. So when the first time a component is called, that is akin to you telling the waiter what you want. And the waiter is React. So it goes to the kitchen, which is also React, and runs some JavaScript code in your component function and calls in some components, trying to figure out how to make this component. And once React has made the component, it will actually serve it to you. So that will be taking that generated code and then putting it into the HTML document on your browser. And let's get into the details of how this works with an example. So here we have the web app restaurant again. This is an example of a website that we made. And if you click on this order state component, something is going to happen. A raw state is going to show up. So I guess like you told the web app waiter to get a state, and they got into a raw state. And what happened here was that there was a trigger, which is you telling React that you want to make the state component for the first time. And this is called mapping. Mapping is the first time a component is made and shown to you. And then it renders it, so it figures out like this image tag and the other like information on this component, and then it commits it to you, sending it to your browser screen. And let's look at the code to see like what's actually happening here. Here we have the state component, which we've defined and have a new state that has a initial state of 0, indicating the level of doneness. We do some kind of code here that like looks up like what kind of state to show that I have hidden, so don't worry too much about that. And then the sense is to tell the user. And we also have to find a callback function that will change the doneness to increase it by 1. And here we like actually have image element and the button for sending the food back to the kitchen. So what's going on here? You've got your food and it might not be satisfactory. So you're going to send it back to the kitchen. And that is another example of trigger. So trigger and then render and commit will happen, bringing you a new state when you click on this send back to kitchen button. So now we have a rare state, but if you're worried about the red, you might like give you like Ebola or something. So you send it back to a web lab state restaurant kitchen by changing the state once again. And before we continue, let's note something about state. So before we were talking about how you always have to set state using this like set doneness function instead of just going like doneness equals something. And why is this? Like why can't we do that? It's because state is actually the only memory for this component here, besides any props that are passed in. And in this component, there are no props. So the only memory is this state. All this other stuff in the pig box that is down here actually gets recomputed when the render phase happens. So like trigger is when we set the state and make a component for the first time. When we move on to render, everything that is here gets computed all over again. So if you define a variable in here like census and then you try to change it, it's going to be gone. If you try to change doneness, it's not going to be changed on the next like state render. So non-state variables don't persist, and we should not try to do anything to change these variables unless it is within the same like render phase. So I mean, we changed our state to be rare, and then we sent it back to the kitchen. I forgot to give a transition, but it was supposed to make your state medium and then well done. But we sent it back again because well done was nice. And now it's like congratulations state, which is kind of messed up. So now you don't like your state. So you click on this delete state button and the state disappears. And this is called component dismount when you delete the component. So to recap, this itself is the React lifecycle. First, when a component is made, we call that mounting, and that again triggers the trigger render commit cycle. And render is when it figures out like what to show. Commit is actually showing it. Every time you change the state, you have to figure out what to show again during the render phase, and then it actually like sends it to your browser. And in the end, when you delete the component, it dismounts. So now that we understand the component lifecycle, let's learn about the use effect hook, which exists under this cycle. The use effect hook allows you to run a specific function or run an effect, as they say, after a specific variable changes. And this function is typically used to synchronize with external systems, or something external to the typical React paradigm. So you can think of this as sort of a response to a state change, and it's commonly used to load external data into state, for example, from an API that we learned about earlier. And the syntax for this is that it's similar to a use effect use state hook. It is just called in React component function, and then you pass in a function that you want to run every time something in the dependency array changes. And this dependency array is actually an optional parameter, and we'll see why in the next slide. So here's an example of a function that I've defined from my function, and it does something and do whatever you want. And you want this function to be called every time a certain variable, such as a state, changes. So let's say var1 and var2 are states. Whenever you set the var1 state or the var2 state, my function will be called. Whereas in the second version, as using use of that, the dependency array is empty. So this does not depend on anything. So my function will be called every time the component is rendered for the first time, which we call mounting. So this could be, for example, if you want to fetch information from the API just once for your entire component throughout its lifecycle. And you can use a dependency array that is empty. Whereas if you want to fetch something again and again, whenever variables change, you can use the first version. And lastly, if you don't give in a dependency array, it will just run the effect, call the function every time component re-renders. And before we said that this was a really bad approach of trying to figure out what the person's state has in it, if we just like constant log it right after set persons, because The state setter is a asynchronous function. So there's no guarantee what this console log will print. The better way of doing this is that you can just use a user effect that keeps track of this person's function or person's state, and then console log it every time it changes. So it is responding to a change in persons by running this effect. And this will be guaranteed to print out the new value of persons every time state changes. One last thing to note about use effects is that sometimes you might want to clean up something when the component dismounts. So in our life cycle, we have mount, if you want something to happen for one time, like throughout the component life cycle, you can have an empty dependency array. But what if we want something to happen just once at the very end of your component's life? And this is where the cleanup effect, use effect comes in. Cleanup functionality. So in the callback function that you pass into use effect, you can actually return something. And this return statement, you can return a function. And this function will be called every time the component dismounts. And this is useful, for example, in a situation where you're interacting with an external service, every time like the dependency changes. But when that app closes or when that component is closed, then you want to like somehow disconnect from that external service. Then you can put that in the cleanup function of your function that you pass into use of that. And this is a little like nebulous and confusing right now, but you will see this later on and also in our sockets and game lectures. So before we move on, are there any questions from the audience?
Maybe why, like why does impact on
So this is an anonymous function that you learned about in the JavaScript lecture. You can also define the function like somewhere above it and then do return that function. But this is just a way to define a function without giving it a name. Yeah.
All right. Now we're going to have a couple miscellaneous tidbits that might be handy to know and see use effect in action a little bit more. We'll start with get and post. Huang talks about this in the previous lecture today. They're functions not native to the JavaScript language, but that we do give you. And in this code snippet, this get function call is making a call to the address /API/foo and passing in parameters bar with a value of 0 and then logging that when it's done. But anyways, get is one thing in which with which we can integrate into our code using use effect. When you think about the Twitter example that we had earlier, when you first load the page, you're going to need to fetch all the information, all the tweets, whatever that you want, that the browser wants you to see, or that the website wants you to see on the screen, right? But it's not going to change that much from second to second. Chances are, on each page refresh, you're only going to need to fetch all that information once. And so, as Huang mentioned, we can use the use effect to run a piece of code just once at the start of the creation of a component. And this is an example use case of that. We can use get to fetch that data once and then update some state with the response afterwards and let that be it. We can also send data using post. In this example, we're sending data to /API/user/admin with the data of admin, but we're just sending the negated value of admin. So if it's true, we send false. If it's false, we send true. And then we're updating the state variable accordingly. Now this function we've named handle toggle admin. And as you can see on the top here, we have a button element, a button component in which we're passing in this function to the onClick property. This just means that when you click the button, this function is going to be run once, and it will make this post request accordingly. And it's just another way that you can add some interaction into your code. As a reminder, for JSX, it's essentially just HTML, but in a JavaScript file. So here we have the constant variable element. We're just giving it the value of what's on the screen, a H1 element with the following text, nothing much there. And if you wanted to create multiple pieces of content, you can do the same on multiple lines. Here we have both the header and the content, separate elements, but you can refer to them by their JavaScript variable names, header and content. And so in the return expression, we can include these in what we want to render using these curly braces. And because it's valid JavaScript that happens in these curly braces, we can just put in the variables like that, and it'll read as the HTML value, JSX values that have been assigned to them. And this is valid JavaScript. Okay, so with that in mind, let's see if we can create something like a loading indicator. Earlier I mentioned you might be fetching data at the beginning of, or when a page first loads, and before that data comes back, there might not be anything to display, anything meaningful. So instead, you might want to consider displaying some sort of loading indicator for the user to know that they're waiting on something and not just intentionally being given an empty page or whatever that they see. One way we can do this is using something called a ternary expression. If you haven't seen it already, it just looks like this, having a condition on the left followed by a question mark, and then a value that would be used if the condition evaluates to true. And otherwise, the value on the right of the colon would be used if the condition evaluates to false. And so assuming, just for the sake of this example, we have some state variable loading that can keep track of whether the page is loading or not. We can use this ternary operator to determine what we want to display based on whether or not the page is loading. So in the first half, if loading is true, then the expression that it would use is div title and then loading by Bitcoin while waiting for the page to load in the paragraph element. And then otherwise, if loading is false, it would use what's on the bottom instead, and you can render something different. But we can make this a little cleaner, because there's a lot of repetition here, right? There's the div container element. There's the title that remains the same. And so we can try making this more modular by keeping those constant elements there, and instead writing the ternary operator outside of the return statement. So this does exactly the same thing as what was on the previous slide, but we only use the ternary operator to determine the what we display in the differences, or like what different parts we display. What remains constant is just in the return statement already. We can actually make this even more concise by writing it directly into the return value. As I mentioned before, and as you've heard multiple times before, you can just write JavaScript with inside curly braces in the JSX pieces of your code. And so we have div title, and in the paragraph tag, the string that ends up being rendered, we can just determine that based on whether or not it's loading, whether or not loading is true or false, by using a ternary operator. Same idea, just a little more concise. And then loop rendering. For loop rendering, sometimes you might find that you have a list of different elements, like in the previous example, if you had a list of tweets, you want to render all of them, all the elements of that array of data onto the screen. Now, React doesn't immediately understand an array of like numbers and letters. You need to give it JSX in order for it to put it on the screen. And so we can use the map function that you learned about before to do that. So when we have an array of data, like my array up here, we can just map it to, oh, sorry, this is a review. This is how you use map. If you call .map on an array, you pass in an anonymous function, and it will return, it'll map each value in the array to a new calculated value. In this case, we're just doing x becomes x times 3. So my array then becomes, or modified array then becomes 3, 6, 9, 12, 15. And then it's just another example down below. But for the sake of time, I will skip that one. You can look back at it if you need to later. But anyways, using map in React, let's say we have this data here, four elements in this array where each element has an ID number and a name. React doesn't know what you want this to look like. So we use map by okay, wait, sorry. Like this, or, okay, I guess the code comes after, sorry. We use map to map each of these elements into JSX. And we pass that, we do that by passing in a callback function, the same way that we saw on the previous slide. Give React something that it can render. And so it would just look like this. We have the data, data.map, and then each item becomes a div element where the key is the item ID and the contents is the text in that element. Yeah. And similarly, instead of just doing that with div elements or native HTML elements, you can do that with components as well. If you create a component that is meant to display each of those elements, a component that you made, you can do the same thing and pass in those pieces of information from each element of the array as props or something else. Or, yeah. We can skip that. We're short on time. Does anyone have questions so far? Okay, cool. All right. So we've given you, up to this point, we've given you a lot of information on React. Now we can take a look at an example that puts together some of these ideas in a fuller component. Let's say we're trying to create an element that keeps a component that keeps track of time, like a clock of some sort. With this starter code, I might want to start off by thinking about what kind of state I want to keep in this element, or sorry, in this component. Does anyone have any ideas what we might want to keep as state for something that keeps track of time? Like a constant? So for something like that, we can probably just write it out in the code itself without making it state, because it won't change from one render to the next, right? Yeah. Any other thoughts? What state might we want in something that keeps track of time? Yeah, time itself. So I'll start off by creating a state variable that does that holds information about time. And I'll initialize it with a value of 0. And then for the render, it'll just be something simple, a label of the word time followed by the value that's stored in the state variable. And okay, so now that we're keeping track of what time it is, just by having a state variable, we want something that can update it, that can count the time. They'll start some sort of internal timer. But we also only need one for the entire lifespan of this component. We don't need like 6 timers running simultaneously for this one component. And so in order to do that, this is a case in which we can use the useEffect function, and specifically the variation in which we pass in an empty dependency array. So as Kwong mentioned, useEffect in this way will run the callback function that we give it just once when the component mounts. And this makes sense because we only want the timer to start once. We don't need multiple, right? And then to actually start the timer, just as a refresher, does anyone have any ideas about what we can use? Something from the JavaScript lecture that might come in handy. Not on click, something that will get something running in the background. Yes, set interval, correct. So with set interval, we will run this other callback function that we create every 1,000 milliseconds. Well, 1,000 because that's what I'm passing in. And all this is doing, what code just showed up on the screen, all this is doing is incrementing the time variable by 1 every second, because we use set interval. Now, one thing to note, this syntax might look different when I'm calling set time. Instead of passing in a value, I'm giving it a function instead. For now, you can just take my word that it does what I said it does. But if you're curious about why we might use callback functions instead of values, or like when it might be handy, there's a slide later on, or just a link you can access later for our full React guide, where you can jump to a page that'll explain this more in depth if you're curious. But for now, you can just trust me on this one. It will increment time by 1 every second. Now, we're not quite done here, because when this clock component dismounts, this timer that we've created remains existent, right? It's going to be running in the background because it's not inherently, part of the clock component. The way set interval works is it starts the timer in the back and then it'll just keep running. And so something we need to be mindful of is cleaning up when it's appropriate. And in this case, we return a cleanup function to clear that timer whenever this clock dismounts. And now this is basically our clock component that will display the time and count every second. Before we're done, I would like to show you guys just how much of a difference this return statement can make. So while leaving a timer in the background may not sound like the most harmful thing in this example, it can do a lot more if you can run into a lot more problems if you don't properly clean up. Like, some parts of your website might stop running, or you might have your computer slow down and you might not be able to know why, because everything in your code looks like it works correctly. But in this case, I'm going to jump over to an example where you can see just the effects of that. So just a heads up, what you're going to see in the next slide is a recording of said example, where on the left is going to be something like this screenshot over here. On the right, there's a toggle clock button followed by the clock component underneath. And on the right, there would be a console that basically logs every tick. Just imagine that I added console.log for every tick, or in the callback function that I passed into set interval. So just as a quick note here, we have some conditional rendering here, as I mentioned earlier, with show clock. What button does, or what it's supposed to do, just to simplify it, I've kept it commented out, but it's supposed to change show clock from true to false on every click, or false to true. And when show clock is true, it will show the clock element like that in the middle of the ternary expression. And if you're wondering about what causes a component to dismount, this is one way to do it. So when show clock becomes false, we will then, instead of showing the clock component, just something that, well, an empty string, so nothing. And then the clock is then dismounted and it will be off the screen. So now this is what it would look like without the return statement there. I can't control when the GIF starts, but the first frame is when the console is empty. So like right there. Okay. So the clock is visible, it's ticking, and then I take it away. We actually get an error from the console telling us there might be a memory leak and just in general, something's wrong, right? And then I toggle clock off and on a few times. And eventually you can see the number next to tick, it increases more than once a second. That's because every time that I destroyed the clock and I created a new one, I added another timer. But the timers that were associated with the previous clocks, they weren't cleared. And so we just have a bunch of timers running in the background, and you wouldn't be able to tell as you're interacting with the website. Even something like this, if someone spam clicks this off frequently enough, you might end up with a laggy user experience. Now, what does it look like when you have that return statement there, when you do clear the timer? Well, it works as expected. We have the clock on and it ticks only when it's visible. And then when it's gone, nothing happens. No timer exists. And yeah, so that's just a small but hopefully insightful example of the importance of having the return statement when it's appropriate. Okay, so we were hoping to get to a little more, but for the sake of time, because we were behind earlier, we're going to skip the last few slides. And but if you're curious and you want to learn more about like the math library in JavaScript or the date objects or sets, these might be handy to know. These slides are accessible on the website under the schedule tab. And yeah, that's about it. And this is the link for the React guide as mentioned earlier.